Hey there, and welcome to the Daily Space Weather. I'm your host, Dan, a.k.a. Smash-a-Mash, coming at you from the Smash News Network, least busted name in news, just bringing you some more fresh imagery of the closest star and the most comprehensive daily space weather you'll find in the known universe. First thing we're looking at here is SDO imagery for the past 24 hours. That's 193 plus 171 angstroms. There were a couple of M-class flares in the past 24 hours on a rapidly developing sunspot right in the Earth-facing portion of the solar disk. We'll get to it. That rapidly forming sunspot formed down here somewhere. Don't worry, we'll show you some detailed imagery of that. We've also got this prominence swirling around. It just in the past few hours becoming a coronal mass ejection. There's a great view of that filament spooling up and then beginning its blast off there. Another crown prominence. There's also a huge filament around the north polar region. We'll show that here momentarily. Two new sunspot groups have recently risen in the east. And the one in the northeast is the one responsible for the M-class flares. Here you can see a huge filament encircling the north heliographic polar region. And we do have a very high likelihood of major solar flares as the day progresses. So anyway, thanks for tuning in to the Smash News Network, least busted name in news. Congratulations on realizing that the channel exists. Here's yesterday plus today in the SDO intensity gram full glory. And if you look at the last few frames down here, you'll see right in this area, you see this blurry looking sunspot forming. If that's really a sunspot, it certainly formed rapidly. You'll see some indication that there is something happening down there on the colorized magnetogram as well, right down in this area right here. Some oddities happening there indeed. Let's take a brief look at what's going on planet Earth before we get back to space. So we've got a new volcano on the list, Barren Island, located in the Indian Ocean. Let's start out with Semeru on East Java. It is producing a 14,000-foot plume of volcanic ash. Don't pole vault the caldera at Semeru. It's producing a 14,000-foot plume of volcanic ash. It's a flight level 140. Dacono also exploding. That's a 600-meter ash column. Popocatépetl showing a flight level 200 there as Popocatépetl explodes in central Mexico. It's a 20,000-foot ash plume. Fuego in Guatemala exploding, flight level 160, 16,000-foot ash plume. Sabancaya, 24,000-foot ash plume over Peru. And again, Barren Island there, exploding in the Indian Ocean there, producing a flight level 150, 15,000-foot plume of volcanic ash as it explodes onto our list. We've also seen a big uptick in earthquakes over the past about 12 hours. A bunch of quakes in the 5 magnitude range that we'll be covering here in a moment. That's the past 90 days in convenient bar graph form. And let's check out the list from USGS. Again, we saw a big uptick in 5+ magnitude quakes just in the past several hours. So in the past 24, we did have a 5.1 at Indonesia. That was at 16:29 Universal Time yesterday afternoon. Also, Kermadec Islands early this morning at 0 dark 16. A 5.1 at the Kermadec Islands. So starting out May with quite a few 5+ magnitude quakes, like a 5.1 at the Ryukyu Islands there, south of Japan. That was at 2:21 this morning. And only a minute later, a 5.3. So that was a great example of a foreshock there, the 5.1 and the 5.3. Maybe those are foreshocks for a larger quake. And then only, 19 minutes later, there was a 5.2 at southern Italy. And then less than an hour later, a 5.9 at Japan. So the 5.1 and 5.2 were both foreshocks. Perhaps the 5.9 was the largest quake. There was also a 5.0 at Japan. That looks like an aftershock. and a 5.1. Also saw a 5.4 aftershock and a 5.2 at northern Peru. So a big uptick there. Remember, folks, any earthquake can be a foreshock. And let's return to space. Here are the past 24 hours in the house favorite wavelength, SDO 171 angstroms. So great stuff there. Again, some new sunspots here. Here's 193 angstroms as well. Good at showing coronal holes, the extended corona and filaments. And the 10.7 centimeter radial flux still toying with those support levels we talked about last week. The 10.7 now at 154 solar flux units. There's the 1 year graph to put it in context for you. The black line is the 10.7 centimeter radial flux. The red line below it is the sunspot number. Perhaps you can see how proportional those data sets are. Sunspot number and radial flux, they're directly proportional to each other as we see solar sunspot cycle 25. Yet to reach solar maximum. Yeah, I don't care who's been telling you on YouTube that we're already at solar maximum. We just aren't at solar maximum, so they can keep saying it. They can keep chanting whatever they like. On YouTube, it doesn't make it true. Now you can see some geomagnetic unrest forecast here by NOAA, actually. So on the Space Weather Enthusiast dashboard here showing geomagnetic unrest late in the day tomorrow. No indication what the reasoning for it is. Is it a CME impact? It doesn't even show it on here. So not exactly sure what's up with that. NOAA doing some weird forecasting. We're still expecting a minor glancing blow for a CME impact today. And NASA has also changed its forecast here. So here is the forecast from the Integrated Space Weather Analysis Center. And they're now modeling the CME that we forecasted to strike really at any moment now. We're expecting to see this arrive sometime between now and the end of the day today. So May 1st, we're expecting a minor CME impact. We don't expect the KP index to get above 6. Possible KP 6 for a brief period of time is likely. Not sure how they decided to change that forecast, but let's take a look at Earth's magnetic moment from space. Here is our geospace magnetosphere movie, and things are quite calm. So if we do see a CME impact, there should be a good signal from it. The past 4 hours here, quite geomagnetically calm. We've got a very diffuse solar wind, and not particularly fast either. That's magnetohydrodynamic pressure for the past 4 hours. Here is magnetic flux density at the surface level. And we show this one daily because a lot of people are frightened that Earth's magnetic poles are going to reverse because they've been consuming a lot of nonsense on YouTube, for example. Hopefully you're not consuming too much nonsense on YouTube. I know there is certainly quite a lot of it, as people are incentivized to the tune of millions of dollars per year to just straight up misrepresent science publications and convince people of utter nonsense about cosmology. So that's the past 4 hours of Earth's magnetic moment from the ground. Here's an average of Earth's geomagnetism, the KP index, currently at 2.66. Again, it's a geomagnetically calm situation. And let's take a look at magnetic data next, as well as the rest of the solar wind telemetry here from Lagrange point 1. Now, we just recently did have a switch over here just before midnight yesterday. That blue bar down there at the bottom, that is the switching from the ACE to the Discover. Now we've got both providing data here. Current conditions are still slightly elevated solar wind there at 479 kilometers per second for the solar wind speed. Solar wind density here, 1/4 of a proton per cubic centimeter. So very, very diffuse solar wind density. Besides that, pretty unremarkable. There was just a little shift in the fields here. So you can see right up here the phi angle as well as the BTBZ here shifting. Besides that, again, pretty unremarkable for the past 24 hours. Here are the GOES magnetometers, the GOES 16 and GOES 18 from their geosynchronous near equatorial orbits. We are seeing some major charging hazards here. At least we were when we did show prep. We'll get to that in our bonus feature segment. Next, the top view ecliptic plane field plot depicting the polarity of the heliospheric current sheet. So Earth has, in the past several hours, snapped into a North Pole-oriented current sheet depicted here in green. North Pole current sheet has arrived, folks. So welcome to the North Magnetic Pole of the heliosphere. Here is our line of sight field plot. You'll see those green North Pole-oriented fields rotating in and the south red-colored fields rotating out. Solar B field depicted here in blue. Let's move to coronal holes. And we've got some quite significant North Pole-oriented coronal holes rotating in here. And another important factor here is that there is still quite a bit of north polar magnetism at the north heliographic pole. Very obvious in that imagery right there. And until that leaves the north heliographic pole, we will not be at solar maximum. You can see that, as far as we can tell, there is zero south pole magnetism at the south heliographic pole. The north pole magnetism has yet to fully leave the north heliographic pole. And let's take a look at coronal holes here from SDO. So there is the spectacular 211 angstroms wavelength. And the sector boundary crossing is right here before your very eyes. South Pole current sheet is over here. North Pole current sheet is over here. And next we'll move to sunspots. So here's a sunspot situation. Again, we saw this oddity happening down here. It looks like that is a legit sunspot. Not exactly sure what's going on with the imagery. We'll show you some close-ups of that here in a moment. It could be caused by some data loss or something like that. We do have a high propensity for solar flares. I would say the most likely spots to see a large flare would be the southwestern corner and the northeastern corner. So we've got a very large sunspot group here, namely 3288. Setting down here in the southwest, that's very likely to produce large flares. So that's a reason to be streaming live all day today. And let's take a look at sunspots on some custom HelioViewer movies. So I would attract your attention down here to this area. Right here where my pointer is. You're going to see a series of large-looking sunspots just rapidly form there. A prime example of how the magnetic environment can change with basically zero warning. Yeah, so that's a weird one. Never quite saw anything like that before. Here's a close-up of that. This is the south-central portion of the solar disk. And right in this area here, just above my pointer there, you'll see a sudden darkening, as if several sunspots opened up and then vanished again. So I'm not sure about that one. Let's just take a look at the rest of our groups here. Here is the northwestern limb. Some degradation going on up there. The southwestern limb, not so much. Very magnetically complex and large groups of sunspots there approaching the limb and increasing the likelihood of seeing a large flare, including X-class flares. So that is the most likely place to see large flares, in my opinion. If you've got a different one, let us know in the comments. Here's this group in the northeast. That's also a decent-sized sunspot group, and it is magnetically complex as well, at least beta-gamma class, perhaps even beta-gamma delta class. And don't worry, we haven't forgotten about the new groups rising in the east. There is the producer of some M-class flares in the past 24 hours. And we've also got another group in the southeast, just rising or perhaps forming. So we're expecting another sunspot group to get a name down there. You'll see that perhaps right at the end. Anyway, we'll show you high-res imagery of that later in the video. Next, let's go to energetic particles and solar flares. So the ghost proton flux here, no solar energetic particle events, no relativistic particles for the recent past 3 days at least. Again, we had 2 M-class flares, the largest of which was an M2.36. Peak flux was 2030 yesterday evening. And here are some great wavelengths to view flares, 94 plus 131 angstroms. Here's a little closer view. And we've also got the most active sunspot of the past 24 hours, producing no less than 2 M-class flares. And you'll probably see that image all over the internet on channel thumbnails. Now, quick reminder, if you haven't created a Twitter account because you don't use social media, well, we don't blame you for unplugging. However, if you are on social media, make sure you follow us over on Twitter. By the way, we've recently picked up another way to endorse things for you, our Amazon shop. So if you head to amazon.com/shop/smashomash, or you can link directly to it there on the Twitter feed. It's pinned to our profile. Look for more products to be added soon there. At the moment, we've just got supplements and coffee and some assorted things. So check that out. If you're in the market for supplements or coffee products, why not buy it through our Amazon shop? Helps to support the channel that way. Next, taking a moment to look up, as that's what's going on over Lehigh Valley, Pennsylvania, despite it being, well, I think it's clearing up actually, but it's still a little bit cloudy. And the Sun and Mercury very close together there in the eastern sky, as the Sun chases Jupiter across the ecliptic. And it's great viewing, by the way, for Venus. If you're looking up after dusk, you'll see the third brightest object up there, most likely if you've got clear skies. And here comes a solar system forecast. So here is where things are now. And we'll advance this 1 week as the terrestrial planets face off against the gas giants. It's a clear demarcation line. Gas giants over here, terrestrial planets over here. And if that frightens you, you should press unsubscribe. Here's where things will be in a week on May 8th. Yeah, May 8th. And let's take a look at coronagraphs. So there were certainly some CMEs yesterday. Here's 99 frames of computer-aided coronagraphs, or CACs. I just made that up. Computer-aided coronagraphs from George Mason University, by the way. We don't anticipate any of those CMEs to be earthly directed. There was a little bit more activity happening when we did show prep early this morning. There are 37 more frames. We're likely to see a CME actually happening right now, coming out of the southern limb, as there is a prominence, a crown prominence, that is in the process of ejecting as we stream the video. So we've also got some additional 24-hour videos, as we do most days. Another great example of a CME here. It's what I would call a hollow core CME, as it's kind of empty in the middle, but it has quite dense outer shells. There's a little closer view. No indication that those are earthly directed. Those are well away from Earth. Again, we do have this prominence down in the... This prominence right down here is in the process of at least partially ejecting, as we stream the video. We'll also show stereo A here. Let me just pause this. Another prime example here of a CME. So here's another great example. You've got a very dense region out here and a much more diffuse region out here, and then you've got basically empty space, and then you've got an even more dense region in the trailing portion. So that is one of the many things that we see when it comes to CMEs. You know, it's different types of features, and we typically see those reflected in the solar wind telemetry. You'll see like a kind of a strong field, and then you'll see a lull in the activity, and then you'll see an even stronger field and higher densities and things like that. And thanks for leaving comments. One Audio. Continuing to filaments. And yeah, still a lot of filaments on the Earth-facing portion of the solar disk. Quick reminder, I say it all the time on the channel, you don't need to see sunspots or even solar flares to see coronal mass ejections, as these filamentary absorption features here, or perhaps the brighter prominences, all of which are solar filaments, could be ejected without any of that activity like flares and sunspots. We even figured out how to forecast coronal mass ejections. One day, maybe we'll even take that up again. So yeah, lots of filaments. If you want to name filaments after living people, follow the hashtag #NameThatFilament over on Twitter. We've only got, I think, one named filament at the moment. This one up here, it's called the Remco Evenepoel, named after the Union Cycliste Internationale world champion, the world champion of international cycling, Remco Evenepoel, having won the Liège-Bastogne-Liège Spring Classic while wearing that lovely rainbow gold, rainbow world champion jersey. Again, if you want to name filaments after living people, join us over on Twitter and follow the hashtag #NameThatFilament. Hashtag #NameThatFilament. And here are the past couple of hours. Again, there is a CME propagating as we stream the video. So right down here, this prominence here, it looks like more of it is collapsing than ejecting. So we don't expect that to be earthly directed. That's the past 24 hours from SDO. And here's the past about 2.5 hours from the, it's now the GOES 18 SUVI. So it looks pretty similar to the GOES 16 indeed, with its great wide field of view. And let's get to bonus features. We don't want the video to be too lengthy. We'll start out with satellite charging hazards, and we've got major satellite charging hazards here. So that could be affecting the SDO's imagery. Those weird sunspots we saw in the southern hemisphere, those could be affected by these major internal charging hazards. Check it out. We've got most of the planet here under significant internal charging hazards caused by high energy electrons getting inside of the internal circuitry of satellites there. You can see that red bar all the way around the world there. Internal charging hazards everywhere. And also some surface charging hazards there over the Central Pacific, Eastern Pacific, etc. That's from the Satellites Community Dashboard if you want to follow that yourself. The GOES electron flux here, it looks like it's leveled off, so we didn't see as high levels yesterday as the previous day. This looks like the peak in the electron flux of this current electron storm, really. But currently in warning levels there for the GOES 16 and GOES 18. Here's the forecast model. NOAA forecasting a continued decrease. We could see a precipitous decrease there if we do see a CME impact. I'm expecting it to be minor, so not really expecting a large decrease. I'll agree with NOAA's forecast here. And here's the one-year graph to put it in context after we just came out of the longest electron drought in the past year. So now back up to moderate to high levels of electron flux, and that is measured at the F layer of the ionosphere. So we'll also show that, which has been continuing to be puffed up following the strongest coronal mass ejection impact in over 20 years. So this is the vibrational frequency, the raw vibrational frequency, megahertz, millions of vibrations per second. The vibrations of the very diffuse gas at about 300 kilometers of altitude, the F layer of the ionosphere, which is appropriate to consider the bridge between Earth and space, the upper thermosphere. Here's the anomalygram. It'll show you anomaly in megahertz from a 30-day median, and lots of red showing up there, as the ionosphere is taking quite a while to relax following that extreme perturbation from a perfectly directed coronal mass ejection impact. So there you go, that's what's going on. The ionosphere is still quite puffed up, although it is calming down. We'll bring up the latest image and move on to the total electron content. There is 11 o'clock universal time ionogram, and there's 11 o'clock universal time anomalygram, anomaly in megahertz from a 30-day median. The total electron content depicts the free electrons from your GPS satellite down to your handset. So you've got free electrons out here, also in the outer plasmasphere, the inner Van Allen belt, the inner plasmasphere, and the ionosphere. And those free electrons can cause signal refraction. It's a run of about 12,500 miles. And here is the total electron content forecast. This will show you the most likely places to see GPS errors. It also gives you insight into what's going on in the coupled thermosphere, ionosphere, plasmasphere electrodynamics. Everything is fairly organized here. There are some perhaps unexpected GPS errors likely to happen there, but things aren't too out of the ordinary with the total electron content. Last but not least, for our space weather portion, we'll show the latest intensitygram and latest SDO magnetogram. Definitely got some oddities there showing up in the magnetogram, perhaps from satellite communications difficulties. In that area down there, not really looking like a sunspot, although perhaps, so I don't know. We'll just have to wait to see what happens there. Here's your full disk rockback. And do we have another sunspot over here? That looks like a sunspot there also. There's also one there, so we may have two new named sunspot groups in the southeast. If you're worried about the sun shutting down, you can stop worrying. Come out of your bunker and make hay while the sun shines, because it does. Let's move to meteorology. We're doing some wave chasing to start out our meteorology segment today. And the world's largest waves are in the Southern Ocean here, south of Africa. We've got some 36-footers down there, at least 36-footers. There's some pretty decent waves indeed, the world's largest. In the Southern Ocean there, between South Africa and Antarctica. Much calmer on the rest of the world's oceans. We've got the coloring here is significant wave height, and the animation there is the surface wind situation. So let's take a look at that next. There is the surface wind scenario for the eastern world. Here are the jet streams. We show them daily on the channel. We used to separate our videos, and guess what that did? It led to less views on YouTube. So for a monetized channel like ours, we decided to put them back together. Most of our viewers seem to appreciate that anyway. These are the jet streams of the Western world. A huge bend down here in the Southern Pacific, and meridional jet stream flow raining across the North Atlantic, the North American continent. Looks like Charlie Brown's shirt up there. That is indeed some significant meridional jet stream flow. Next, Surface winds. Got a strong onshore wind here at New England. Surface winds of the central world shown here. And the jet streams of Europe, Africa, and the Middle East depicted here. We'll also show clouds and fog over the Americas. That's our 3.9 micrometer infrared radiation map. It will depict clouds and fog despite half of that map being dark. So when you need to know if it's cloudy or foggy at nighttime, try the 3.9 micrometer infrared radiation map, the NASA GOES Interactive Weather Satellite Suite Shortwave Radiation Map is what that is, the shortwave radiation 3.9 micrometers infrared spectra. And here's your weather.gov map. Please heed your warnings on this map. If your location is lit up, head to weather.gov and click your location. We've briefly scrolled down to show you the key. And one of the stories will be hydrologic outlook. Hydrologic outlook. Major snowmelt continues, especially west of the Rockies. Here's your temperature anomaly forecast based on a GFS model for the next 72 hours. Again, anomalously warm temperatures there, especially for the northwestern portion of the country. California getting anomalously cold temperatures, along with everything east of the Rockies, for the most part seeing anomalous cold. That is in degrees Celsius, your 72-hour GFS temperature anomaly forecast. We'll also show the accumulated positive snow depth change forecast, since snow continues to fall into the month of May, with some significant snow in California, Wisconsin, Michigan, Pennsylvania, Virginia, Ohio, New York, Maine, and more. That's your 72-hour GFS accumulated positive snow depth change in inches. We've also got pressure and precipitation based on the same model, as we've got a low which is just circling around Lake Huron here. The Great Lakes region there, low pressure is going to be hanging out for a couple of days. That is your GFS 72-hour pressure and precipitation forecast. And let's take a look at windy.com. There you can see that low, huge anticyclone here off the coast of California. And thanks to our viewer who came up with the brilliant idea yesterday of it sucks and it blows. Why? Well, you can actually see it happening here. Why? Because you can see high pressure right here. You can see wind radiating outward from it. That's a high pressure zone. A low pressure zone, you can see wind blowing into it. Why? Because lows suck and highs blow. Anticyclone is high pressure, and a low pressure is obviously low pressure. Anyway, that's your your atmospheric physics breakdown for the day. And just bear with us a quick moment here while we bring up the next slide. Hey, windy.com. They got a great mobile app, by the way. Windy.com. They do not yet pay us to say that. I endorse the product. So here's our NASA GOES lightning mapper. Looks like no major terrestrial lightning here in the U.S. There was a little bit in North Carolina, but besides that, things pretty chill. Here's your real-time lightning mapper at lightningmaps.org. No terrestrial strikes in the U.S., apparently. And let's move on to our U.S. Doppler radar. Clouds and fog for the lower 48, unless it's timed out, in which case, well, wait for it. We apologize for this temporary aside, and we are hoping against hope that the browser All right, should I start breaking stuff? Let us know in the comments if you think I should start breaking stuff. I'm considering it. Considering starting to break stuff. Don't worry, folks. We are actually in the process of upgrading our hardware here. So that should help things. We'll have more RAM. We'll have a second PC and so on. So just give me a minute here. We'll put up the aforementioned water vapor map. There you go. And also the clouds and fog map. So there's that. There's water vapor. You can see great imagery there of that rotating low there just west of Lake Huron at the moment. And here's your recap to close out the video. U.S. Doppler radar. Shortwave radiation, 3.9 micrometers. And 6.19 micrometers showing the water vapor. Thanks everybody from Smash staff and I for tuning in. We appreciate your viewership. And if you want to support the channel, you are invited to do so. One of the ways you can do so is by visiting the links below the video. Check out the merch shop if you haven't done that. I'm currently wearing the Galactic Federation Special Forces product. So here's a Universum Liberate to each of you. Yes, because if I could wave my magic wand, I'd set everybody free. If that sounds a little bit too reckless to you, well, it's because I'm not frightened. So there's a reason why we lock our car doors and the doors of our residence. The reason is because we want to protect the outside from us. You see where I'm going with this? So, yeah. To quote Geddy Lee, if I could wave my magic wand, I'd set everybody free. So I say to each of you, Universum Liberate, if you're sick of what's going on your planet, or perhaps in your solar system, why not support the Galactic Federation Special Forces by showing your support with some merch and saying to your friends and foes, Universum Liberate. You can also support the channel by visiting the Amazon shop, which is now conveniently on our homepage. Also on the Smash Team site at smashomash.com/SmashTeam, the official subscription services site of this channel. Consider becoming a gold or silver Smash Team member for some additional content, mainly to support the channel and continue the likelihood that these videos will exist, remain publicly visible, and free for all to view. You can also find our Discord chat invite. You can find a link to the Twitter, to the YouTube channel, etc. There's also a bronze level at the Smash Team. We send out email alerts for things like natural disasters, usually before USGS does. Smashomash.com/SmashTeam. You can also find links to our affiliate/sponsor, Hemp Lucid. So check out those products, and make sure you don't forget to enter the promo code SMASHOMASH to save some dough on checkout. The promo code SMASHOMASH, links below the video, as well as on our homepage to that homepage being smashomash.com. And once again, welcome to the Neo Renaissance. Again, thanks to each of you for tuning into the video. Please press comment, share, like, etc. If you're new to the channel, press the subscribe button, press the notification bell, and sign up for email alerts over at smashomash.com/SmashTeam, especially if you don't trust certain organizations to notify you when we put up a video. In any case, thanks once again for tuning in. In the meantime, I'll have been your host, Dan, a.k.a. Smashomash, signing off. And may that solar wind be at your back.